Alright, this lesson for day 104, change of base formula. Your goal today is you'll be able to evaluate logarithms by using the change of base formula, which is another formula. You might not need this if you have a right calculator, but a lot of people, you don't have access to like a more advanced calculator, so this is something you do need to know how to do. Okay? So let's think about where we've been so far with exponential and logarithmic equations. So the other day when we started, we said log of 10. What's log of 10 equal to?
1.
1. What's the base in this log? 10. The base here is 10, remember? This is a common log. Remember common log yesterday? Cool, let's keep going. What's the common log of 100 then? 2, right? Cool. So, and then yesterday we talked about this. We're like, well, what about a common log of 50, right? And we predicted it was going to be like 1.5, right? Remember doing that? Right? And then we actually put it into the calculator and we got, what did we get? 1.7. And if we rounded it to the nearest thousandth, it was like 1.699 or 1.698, right? So, was that it? Okay, cool. So, now what if we had like log base 5 of 5? What's log base 5 of 5, everyone? What's log base 5 of 5? 5 to what power is equal to 5? What is it? 1. Good. Okay, now a trick question. What's log base 5 of 25?
2.
Good. What's log base 5 of 125?
3.
What's log base 5 of 1?
0.
Okay, good. What's log base 5 of 625?
6. 4.
Right? You see what I'm doing? 1, 2, 3, 4. Y'all see that? Okay, cool. Now I got a question for you, okay? I got a question for you. What is log base 5 of, let's say we put a number here, log base 5 of 10. What's log base 5 of 5 again? Log base 5 of 25? 2, right? So what's log base 5 of 10?
1.67.
Yeah, but maybe 1.5, right? 1.67 maybe, okay? Is there a log base 5 button on your calculator? Everyone pull out your calculators.
iPads and phones.
iPads. You can pull out your phones too, that's fine. Just don't be off task. Okay, is there a log base 5 button on your calculator? No. What 2 buttons do you have on your calculator?
Log 2, log 10.
Log 2, and then what else?
Log 10.
Log 10, and what else?
Ln,
right? Natural log, base E, right? Do we have a base of 5 anywhere on that calculator? No, and that would be ridiculous, right? We'd have to have a base for everything. Log base 6 button, log base 7 button, log base 8. We can't do that, so we have to change the log so we can use the calculator, okay? So, here are the steps for today. If you're on the video, you should pause it here and write them down. Alright, so here we go. Log base 5 of 34. Eyes up here, I'll show you how to do this. Okay? Log base 5 of 34. So I know that I don't have a base 5 button on my logarithm, or on my calculator. That's a log base 5 button. Okay, so, but I could predict it, right? I could get some idea of how much it's going to be. What's log base 5 of 25, everyone?
2.
2. Log base 5 of 125?
3.
Good. So where is log base 5 of 34 going to kind of be? Closer to 2, right? It's going to be between 2 and 3, right? Okay, good. So, this is how we do this, okay? We have to use the change of base formula so I could use my calculator, okay? So, the way that works is there's this change of base formula. We know that on this original logarithm we had a base of 5, so that'll be the base we're going to use, and this n will be our number that we're going to use. So, Our change of base formula is going to be log base b of m is equal to log base c of m and over log base c of b. Okay? And you're like, oh, that's kind of crazy. It's not too crazy. The b is your 5, m is 34. Okay? The c is going to be a new log base that we're going to pick. What are the two bases we could pick off for calculators? 10 and?
ln, or log.
Yeah, natural log or e, right? So I would suggest always make your c 10, so it's a common log button, okay? Some of us have log base 2 also, but don't worry about that. Let's just do common log, okay? So we're going to always put our c as common log here to make sure we don't have errors. So check this out. Now I'm going to replace all my letters here with the numbers, okay? So log base, the original problem is log base 5 of 34, and it's equal to log base of our new log, our base of 10, because we want to use the common log button. Our m is 34 over log base c. We're going to use the same base of 10 over 5. Okay? Now we're ready to work out the problem on our calculator. So let's all pull out our calculators, and you're going to push the buttons along with me so you can practice as I go. Okay, so I'm turning it sideways so I can get those log buttons. What's the first thing you should always do before starting a new calculation? Clear it, right? We're clearing it. Okay, here we go. So we're going to start here with our calculation at log base 10 of 34. Okay, so let's put in 34 after you cleared it, and then we're going to push the common log button. And it gives us a number. That's just the value of the numerator. We don't need to write anything else down. What does the fraction line represent? What operation? Divide. So we're going to push the divide button once. Okay? Now we're going to do the bottom. We have to put log base 10 of 5. So we're going to push 5. And then you're going to push the common log button, which it'll give us the answer for log base 5. But that's the denominator value. We have to press equals. Okay? And it gives us our answer, which is 2.19105. Okay? So when we round that, we need to round to the nearest thousand. So looking at the 1, look at the number to the right of the 1. What's our answer? Is it 5 or more? Or no. No. So it's going to be 2.191. And that's what I just did. We just rounded it. Okay? Does that make sense, everyone? Cool. So, and that was our prediction, right? Didn't we originally say our answer is going to be between 2 and 3, but closer to 2? Yeah, that's what it was, okay? That's what we're doing. Number 2, let's do it one more time, okay? One more time. Log base 5 of 23, okay? Let's predict. What's log base 5 of 5 again, everyone?
1.
Log base 5 of 5 is? 1. I want to make sure you're thinking. Log base 5 of 25 is?
2.
So what's log base 5 of 23?
2.
It's really close to 2, right? Between 1 and 2, it's like 1.9, 1.8. Good, I'm liking it. So here we go. We're predicting 1.9 about. Ready? Here we go. So we're going to start. We need to set up our equation first. So we're doing some paper writing. Everyone's writing along with me. We got to rewrite this using the change of base formula. So we got the log base b of m is equal to the log base c of m over log base c of b. Okay? We know our base here is 5, and our number here is 23. So we're going to change it. With a new base, we're going to use common log because that's what's available on our calculators. Okay, so we're going to put log base 10 of 23 over log base 10 of 5. All right, and now that we've set it up, we're going to go back to our calculators. Turn them sideways so we get those log buttons if you're on your phone. Okay, here we go. So let's all do this together with Mr. Rink so that you can practice along with me. Clear out your calculator. Okay, we're going to press 23. Press the log button, or the common log button. Then we're going to press divide because it's the division sign or the fraction bar. Then we got log base 5, or common log of 5. So we're going to do 5, and then press the common log, and then we get the common log of 5, but that's not what we're looking for. We want to get the final answer, press the equal sign, and we get 1.9481, right? Didn't we predict it's supposed to be really close to 1.9, right? Now let's look at this last thousands place. It's an 8. Let's put the number to the right. Okay, the number to the right. What is it? 5 or more? So do we round the 8 up or keep it the same? Keep it the same. So we're going to write our final answer as 1.948. Okay? A little bit harder than before, but you think we could do this?
Yeah.
Yeah, definitely. Okay, so today is, let's hear some discussion. I'm going to pause the video here. All right, let's do a couple of these. Numbers 3 and 4. Numbers 3 and 4. Just do these by yourself and get the answers. I'll give you about a minute to do these. Everyone's doing 3 and 4 right now. 3 and 4. Go. For 3, everyone, what's the answer?
4, 6, 3.
Okay, remember to the nearest thousandth, so... Okay, 0.463. Okay, and what's the answer for the next one?
5.5.
Okay, let's see if you're right. Yep, 0.463. And we say this 463 thousandths. It's in the thousandths place as the last number. So let's repeat that. 463 thousandths. Repeat. Okay, good. And the last one is 5 and 615 thousandths. Repeat. 5 and 615 thousandths. Okay, good. Whenever you see the decimal point, it means and. Okay. Cool. All right. Let's keep going. Next one. Let's not do 5. Let's have you do number 6. Ready, set, go. Yes. Good job, kids. Some kids are working. Why are you working so hard?
I don't got it. Yeah.
Do it. You're just writing on a problem, right? This problem should take you, what, 1 second, right, to do?
0.1. It's 1.
Okay, 0.1, right? What's the answer, Jonathan? What's the answer? 0.1?
Yes.
No, that's wrong. The answer is no solution or undefined. Is there anything you can raise 7 to the power of to get it to be equal to a negative number? No, we can't. So this one is undefined, no solution, okay? That's it, okay? So that concludes the lesson here.